Hey there. Now, a few days back, Chris Camillo posted a fascinating thread on X. He was talking about the ludicrous potential of Tesla's humanoid robot Optimus. And he was talking about how it could really transform the global economy here on Earth. But there was one part of that thread where he speaks about what is potentially an even bigger opportunity for Optimus, and that is for Optimus in space amongst the stars. And I have to tell you, I completely agree with what Chris said there in that thread. Here on the Over the Horizon podcast, we've been talking a lot about Optimus's potential in space. I've had the pleasure of talking about this with Dr. Scott Walter, who's a mechanical and aerospace engineer, two-time founder of industrial robot companies. He's joining me again today. It's a pleasure to have him. I also have with me for the first time Ozan Belik. He's a software engineer and a self-professed aerospace Greek. So welcome, Dr. Scott Walter and Ozan Bey. Merhaba. Hoş
Merhaba.
geldiniz.
Hoş buldum.
It's great to
Yeah.
have both of you here.
And the same. It's great to see
Yeah.
Ozan again. We're pretty good ex-buddies going back and forth, and I think we've been on at least one video together before. Basically, I have crazy ideas, and then Ozan's able to go through and tell me because he's able to run the numbers. He's much better at running the numbers than I am. I just have like a gut feel, and he's able to tell me whether my gut's going the right way or not. So it's really great to have Ozan here.
Yeah,
Well, it's great to be here with you both.
we welcome crazy ideas here on Over the Horizon. We live in crazy times, and you never know what's going to come true. These are times that ordinarily otherwise should look like science fiction, but here we are. All right, so let me just pull up this. This is the tweet from the thread by Chris, where he talks about Tesla's Optimus division having the potential to hit a 10 trillion valuation. He also talks about sending Optimus beyond Earth, intergalactic humanoids, mining asteroids, and setting up space habitats and whatnot. And we really are in these very interesting times where there's been so much of development in space launches, in robotics, in AI, embodied AI, that I think it's time to just revisit this topic and do a little deeper dive into where we stand and where we're headed. So let me begin with you, Scott. What do you make of this tweet and this thread?
Oh yeah, I mean it makes perfect sense because we've already been sending robotic explorers out into space for the longest time because they're able to go places that we can't. And part of it is because they're able to deal with very harsh environments. But of course, they've been very limited in their capability because they have a certain amount of onboard intelligence, but not artificial intelligence. So they're running a lot of set pieces and what they're supposed to do. And whenever something goes wrong, there's that long communication delay, but then the engineers figure out some sort of clever hack or fix and they get in there and get to move along. So we know these machines can operate. However, they don't have the humanoid form. So we know they're kind of limited in what they're able to do. But the proof of concept is there that we can send these vehicles into a very harsh environment. And we'll talk about what that harsh environment is like and what some of the challenges are to go through.
Yeah. Ozan?
Yeah, I mean, when I first, I totally agree with Scott. And when I first saw that tweet, what jumped out at me was,
let me just pull it up.
That was, thank you.
Pretty crazy.
Yeah, that was kind of like, well, did he really just come out and say that? But of course, with all these things, it's if you look far enough into the future, these numbers that seem crazy, you can make sense of them.
I'll throw a crazy number out there for you. It was on 3 trillion. Why is that number crazy?
Tell me, Scott.
Microsoft just hit that market cap the other day.
There you go.
So we're only talking about a factor of 3 in the future. Okay.
Yeah.
Right.
So and they're not the only $1 trillion company. They surpassed Apple, and Apple was like 2 point something. So we know you can have company valuations like that. So in some ways that's not nutty. However, because the number does seem kind of crazy, Chris admitted in the Spaces podcast that he scaled it back because he didn't think anyone would believe him if he said the real number was like 20 trillion or 50 trillion or something like that.
I mean,
So
Yeah.
he almost had
you
to
can go even higher than that, right? Like if you have
easily.
eight, you know, if we're talking about 8 billion robots, as many
Hmm.
robots as the 8 billion people on Earth, and each of them is pulling 3 to 5 shifts.
Yeah.
What's the real value of that, and why limit it to 8 billion? I mean, if we're talking about solar scale or galactic scale, of course, at that point,
Yeah.
they wouldn't look like Optimus robots, but
I have two
there isn't a
cell
limit.
phones right here, right? And like
Yeah,
another one somewhere else. And like some of my family, everyone in my family has one, maybe two. So yeah, the number of potential cell phones is not the population. It's more, so you can think the same thing about the bots. Like you say, it's like, well,
Right.
yeah, one for home use, one for tutoring the kids. And then, some others that maybe do the gardening. And then also they need to produce stuff for us. So we all have like a part of a bot that's in a factory somewhere. So yeah, you could easily see it could be more than the human population.
Hang on. Do you think the value of a bot on Earth is going to be the same as the value of that same bot or a similar bot in space?
that's a good question. I think even the value of the bot on Earth is going to drop below the value of the human that it replaces. But what what rate that happens at, that's kind of hard to predict.
Right.
Hmm.
Right. And again, when we start talking in the future about these dollars, it's hard to say if we're talking about monopoly dollars at that point, because once you start to get this age of
Yeah.
abundance, there's a good chance there's going to be rapid deflation. So, it's in some ways, because the bots are making well below minimum wage for the effective products, there is like everything's going to start coming down. And that's why it's really hard to say. It's like, is it really going to be a $10 trillion valuation? Because money may have a very different kind of value going forward. But
Yeah.
I definitely agree that, right now, the bots have an intrinsic value, which is probably going to be way more than the cost to actually build them, because they should be simple enough to do. But they're going to be worth almost 10 times what that is to begin with, because there are people that'll be willing to pay $100,000 per year to have one of these bots. So you can already look at it like that. And then, over several years, that means these bots have almost an intrinsic value of over $500,000 or more. That's the revenue stream that the bot maker can get just from one of those things. But as you start to get a wider displacement, and then people are able to afford it, because there's lots of products we have now that you could not afford 20, 30 years ago. Only big corporations had the money, and then the price came down, and then everyone started getting there. So I agree. It's like, no one's going to have this space to themselves, because when you see a pie that's that big, is everyone going to be sitting on the sideline? No. They're like, oh yeah, Tesla's going to have the entire pie. No, there's going to be competition coming in that's going to drive it down. So it's really hard to say what the value is. And I think all we can do, and I agree with Ozan, is it's like, yeah, it'll probably be less, but its value in space may be something completely different, because it may unlock a potential that we can't unlock as humans. So suddenly it's worth less than a human on Earth, but in space, it may have a much higher value than a person.
So think about this. Okay, just how many billions went into the Apollo project, right? And that program is for all means and purposes, it's representative of our biggest achievement as a race in our ambitions to be a spacefaring race, right?
Mm-hmm.
Now, so much of that was concentrated on the human form, astronauts, keeping them safe, the spacesuits, the technology to take them there. So much of that would really not be required for a bot that wouldn't breathe
Absolutely.
oxygen. It could, it could withstand far greater range of extreme temperatures and radiation in these austere environments that any human possibly could. And you could just teleoperate it to begin with. You could start off with Optimus Gen 2 or Gen 3. What's stopping you from doing that? What do you think, Dr. Walter?
It's going to be a question of the environment they're going in that, well, in some ways, there's some things about the space environment that are easier to deal with than on Earth. There are a lot of things that are far more difficult. So in some ways, you could almost say operating in a vacuum might be easier than having to work in an atmosphere that can have like a lot of moisture and, dust and all these other things. So I'm talking about, pure vacuum here. But then, of course, once you get down the surface of the moon, you have dust, which is probably worse than any dust that you have here on Earth, because it's just really gritty and really sharp, because there hasn't been enough erosion to take the rough edges off. So it's like, oh, okay, we don't have to worry about the oxygen causing things to corrode. We don't have to worry about moisture getting in and stuff like that. That makes it easier. But there's going to be this other host of things. And we have this extreme temperature environment where it's both too hot and too cold all at the same time. And then thinking about what your power source is going to be like. So, the Optimus would definitely have to have some changes to it. And of course, the other thing we don't know is what you'd have to do for the radiation hardening of all the electronics. So that's probably also going to have to be upgraded. So you're going to have a lot of seals that are going to have to keep this dust out and some ways of cleaning it. But we know all the things we've sent out there have been able to function way beyond their sell-by date. So if you remember, the first Pathfinder, I think, was just like a 90-day mission, and it ended up being several years. Even the Inspiration mission with the helicopter, the helicopter, that last week just finally had its 72nd and last
72nd,
flight. But it was only supposed to, I think, have like 2 or
5.
3.
Yeah, maximum 5
total. I mean, I think is what they were hoping, and it was only going to last like maybe a couple of months at most. And so we see, even in the harsh environment, we can design these things that they can have a pretty long service life. The thing is, a lot of the times we could extend that service life if we could have someone else, just kind of go out there and just tap something here and there, or just like give a little bit of lift, or a lot of times when things get stuck around here, you just elbow the thing or tap it with it, and that's like all it takes sometimes to get it unstuck. And so, and then, other things that might require a little bit more. So if you have these bots that can help to service the equipment that's out there, that's already a huge benefit. To say nothing about like the number of bots we can send to Mars or the moon versus the number of astronauts.
Oh, absolutely. And speaking of tapping things here and there, I bet NASA, Mars scientists were hoping, they would have given an arm and a leg to have an Optimus on Mars to fix the Perseverance rover that was stuck with a couple of pebbles in its mechanism, its sample retrieval mechanism. And just think about that. Stuck for about 6 or 7 months because of a couple of pebbles. It's a bit ridiculous.
And then also the solar panels, it's like, we remember all those scenes with Mark Watney in the Martian, just going out there and then, blowing it off, just because the dust can end up reducing what is your only way of being able to produce energy in these places. So you need to have effective solar panels. And then the batteries is going to be a trick, but we'll kind of talk about that in a little bit.
All right. It's interesting you spoke about the lunar dust, and I was speaking to Dr. Shauna Pandya a couple of weeks back, and we were talking about the future of human civilization in space. She's a space medicine doctor. She's an aquanaut and an austere environments researcher, and she had something very interesting to say about the future potential of AI, of embodied AI and robotics, and what sort of a role it has to play in the evolution of our space program. Take a listen.
Sending humans to one of the most austere environments that humanity has ever known. And so we need to ask ourselves, how do we not just survive, but thrive on that environment through technology when it comes to communication, when it comes to operations, when it comes to decision making. And I think as machine learning and AI gets better and more reliable and less error prone, AI will be critical for monitoring, detection, decision making, as well as early warnings as to the health of our infrastructure, the health of our astronauts, the overall probability of mission success, and also offering useful interventions. So there is definitely, it really is, the past year and past 2 years have been incredibly fruitful for AI with ChatGPT, with the rise of AI, with its applications for medicine, for science, for engineering, for the internet age. So to be determined where we end up, but there's a lot of promise right now.
Yeah, I mean, this was recorded a few weeks back, and this was before We've seen Figure come out with Figure 1, and before the Tesla earnings call, where Elon spoke about the potential of having an update for Optimus every few months. So the case is there to be made. It's acknowledged by scientists and researchers across domains and fields. Would you say Optimus is ready as of now? How close is Optimus? If we just want to look, if Elon just shoots one to the moon on a Starship like he did, if he could put his Roadster up there, he could just send one to the moon. Let's say in the first Starship, you'd have to have a trial launch to see how it reaches the moon. Just send an Optimus along with it. Do you think the present form would be enough?
It would be able to probably operate there. It just wouldn't be the optimal version of Optimus. So you may get, I don't know, a couple hours, couple of days, maybe if you're lucky, a couple of weeks out of it. But my biggest concern is the batteries and how they're going to kind of deal in that very cold environment that's going to be there. You also need to make sure that you're able to charge it back up. So there's always going to be a problem, but it's in its form. That's why I said we got to talk about the batteries. Because the battery problem has been solved because we've been putting these rovers on planets throughout the solar system, and they're able to function, but they're not your run-of-the-mill kind of battery. There are special batteries that are able to do that. So, the Voyager probes and many others where they have to have battery backup, or even what's going on in Leo, you're constantly having this charging, discharging cycle. So you have special space-based batteries for doing it. I believe what they are is they're known as hydrogen nickel batteries. So they're kind of a cross between it's a fuel cell, a hydrogen fuel cell, and a battery. So you're doing something like that in which the fuel source is literally hydrogen gas, and so you've got to have it under high pressure to be able to do it. And it does have it's kind of like a hydrogen nitride, but it works along these different temperature extremes, has pretty good energy density. It's just that it's kind of very, very expensive. So it's not something you would do every day. It could be possible.
Scott, can I ask you a question there?
Yes.
Do you know if that's what Starlink uses?
I'm not sure whether they're using that or not. I know NASA does, but Starlink maybe not, because that's would be interesting to find out, is because they have to do that. They're in shadow all the time, and they're not using like radiothermal isotope generator or anything like that when they're darkness. So the whole idea is they charge and discharge. So I had to find out whether it's a special type of lithium ion that's able to deal with it, or because of the short periods that you're in the darkness, maybe you're able to do the thermal management a little bit better. Whereas, when it's like you're in deep space, it's like, whoop, we got to have to deal with that constantly.
I have run some numbers on this kind of stuff, and two issues, right? One of them is the number of cycles in Leo, which if you just pack extra batteries, 2,000 cycle life batteries will do fine. If you pack extra capacity, so that it's not discharging fully on each each run. And the other, as you mentioned, is perhaps the bigger issue is the thermal management, which basically just comes down to if you insulate the batteries and have a local heat source, which could just basically be resistive charge going out of the batteries,
or just the battery itself. Sometimes it
generates
a little bit of heat.
It does, and you can have a little resistive circuit to supplement that as needed. So you can have active temperature control and keep it at Earth.
And they can also be like reptiles. I mean, they could just bask themselves in the sun when they're on that side of the orbit. Right. So you're like 45 minutes in, 45 minutes out. So that's not too bad.
Yeah. I mean, you do need a little bit more thermal mass if you want to spend 45 minutes in the shade and 45 minutes, and then what would be ideal for at least a flat back arrangement. But if you have that bit of insulation, that can really make it fairly easy to regulate that temperature, and that I think that would go for Optimus as well, as long as it can handle the. So I mean, these batteries are packed at 1 bar Earth atmosphere. Like I don't know how flexible the material is, and like whether you would have, or like how strong the casing is. So if you did put it in a 0 bar vacuum environment, is it going to try to expand and pop open, right? That would be a potential concern with cells. But if you can prevent that, then I think that a little bit of insulation
Sure.
might be all that Optimus
So-
needs.
Yeah, and
Insulation
you're
plus
right
software.
about the way you set up the pack is you really only have maybe about 60% of the battery that's usable. You want to stay away from going beyond charging over 80 and going under 20%. There's another reason you want to go in there is that you can charge really quickly between 20% and 80%. After that, it tails off. And if you only got 45 minutes in the sun, you're just not going to have enough time to get from 80 to 100%. And then you could say, well, why not go with something that a battery that doesn't degrade, like an LFP battery? So that would be like a lithium iron phosphate battery, because they're really good at being able to do a lot of cycles and going from 0 to 100. Well, it's because you get the same problem with the charging curve at 80%. So it's a little bit heavier. So you could say, oh, okay, what we do is we make sure it has the same kind of energy volume in there for the same mass, but you effectively are also down at 60% because where the charge curves have to be. So it could be that they're doing it with something like that. And the whole idea is Starlink, what's the cost of each satellite? I think it's like around $250,000. It may have changed. I think the original ones were around $250,000. They probably cost a bit more now because it's a little bit bigger, but at the same time, they've probably been driving the cost down because they've been able to figure out what they're manufacturing. So the idea is to be cheap. And what is the service life? Is it maximum 5 years or was it less than that?
So I think the target is 5 years.
Yeah.
I mean, some of them have obviously been decommissioned before that, but I think most of them are still going. And
That's so I think that's service life.
Some of them might run longer, but
yeah.
I think
But it could be, either your batteries are degrading and you're going to do it. And again, the whole idea of batteries degrading, they go from, only be able to hold 80% of the charge. It's not like they completely go dead.
Right.
So there's still something in there. The real thing comes down to the amount of usable propellant. And once you get below some threshold, it's like, that's it. You've got to burn up because space junk.
Let me ask a silly question here. How much of the technology that exists can be repurposed? Do we need to reinvent the wheel when it comes to Optimus? Or can technologies that have worked for human astronauts also be applied, whether it's something like spacesuits?
So I
not
would
just
say
put
that
Optimus in a
spacesuits
spacesuit.
are a very bad solution to the problem. I mean, it's the best thing that we have for humans, but I mean, even for humans, that's actually an area where we want major innovation. If we want something that's functional, that's safe and reliable and easy to work in. Really, the dream has long been mechanical counterpressure suits and stuff like that. You being in this bubble of gas is just not a great long-term solution. And I think it would be funny to put Optimus in one of those, but the mobility issues that it already has, I feel like it would just make it worse.
Make it worse, yeah. The real thing is just protecting sort of the jointed areas from the dust. I think everything else you don't have to. So you try to seal it up. So there's going to be some kind of covers in there, and if you need to, you could just put a pair of overalls on it or something like that. Just not pressurize it. That could be the work. One maybe that's almost the best solution in some ways.
Skin.
Yeah, exactly. With very low resistance, because again, the astronauts get exhausted because just to move their arm, they're fighting the fact that the suit just wants to do this to them, right? So they're going to be out there like that, and then they have to fight that constantly. So they said it's almost like running a marathon after every single one of those EVAs, which was a couple of hours. They said it was equivalent to that.
Yeah.
And also the way the backpack was designed was very high up. So one of the problems that the Apollo astronauts had was constantly having to fight against tipping over.
Yes.
And the joints and all of that. It was so of course we're supposed to be in the golden age of spacesuit development. SpaceX is working on an EVA suit for, I think it was Polaris mission. There are applications there. I think there are learnings to be taken from there, and perhaps, I don't know, maybe adopted it when it comes to Optimus.
Yeah, I mean, I think the MMOD protection layer could definitely be applied. Maybe some of the thermal management techniques. I think that
just put a heat pump on it.
Yeah. So I think that the Polaris suits are using I think they said they're using liquid oxygen for cooling.
Yeah. Yeah.
Which is again not an optimal solution for something that's going to be out there working for weeks and months. There's a lot of mass that you're basically venting. But again, you're operating in a very different environment to Earth orbit. Near the lunar poles, you've got a much less IR from the surface. It's a cold surface, and you have I mean, you don't really have reduced solar exposure, but that IR really changes things. If you have a reflective coat, like you can basically passively manage your temperature, and of course Optimus can handle a wider range than a human. So it's really about protecting that battery and keeping it in the right temperature zone. So insulate it and add a resistive circuit to make sure it's warm enough when it gets cold, when it's in shadow, and then it's and basically protect the joints, as Scott said, and
right.
Yeah.
And the joint thermal management will be interesting. So you probably have to make sure you pick your alloys just right, because you can imagine it.
Yeah,
if you've got one of these joints that one of them like overheats or gets hot or cold, suddenly it binds up. So those will be a few things you have to be careful of. You have to be careful what lubricants you use, because you don't want a lubricant that suddenly solidifies. I think there was a spacecraft back 40, 50 years ago where that was like an issue. It turned out it was like, well, these oil-based lubricants aren't necessarily a good idea. Some of the other things
if you just use Teflon coating and avoid
exactly,
exactly,
which is why I think those coatings were kind of developed almost for the space program because of issues like that, making sure that would work. As far as the Optimus thermal management, currently we believe it's probably just using forced air going through. There may not be liquid cooling, because it doesn't need it while it's operating. Its maximum is about 500 watts, so it probably would be okay air cooled. The real reason that you might need to have liquid cooling is for your recharge cycle, because that's when your battery management system, everything gets kind of hot and you need to do that.
Yeah.
That might be some external thing that you have that when you plug in, you run your coolant loop to that rather than have on there. However, I think a few years ago, James Dalma had done some sort of calculation, thinking about what the thermal management is going to be like in a vacuum with Optimus. And he thought you might have to have some sort of vanes on there as well. So you might have a liquid system where you basically have what look like these wings, which is just going to be for radiative cooling.
Dude, that's like Transformers.
Yeah, in a way. So it's possible you might look at that. I'm not 100% sure that, because it seems like if it's only running at 500 watts, it should be able to dissipate that energy pretty well. But I defer to James that he's gone ahead and done some sort of calculation thinking that there just wouldn't be enough.
So
Optimus Prime.
If you have 500 watts just in the battery pack, I think that could be a problem. But if it's kind of spread out through,
it's distributed, and that's maximum.
It's distributed.
So you get about 75 watts in the FSD. So that's going to be right in the torso. You've got the batteries there; they're going to be producing a little bit of heat, and then you've got the shoulder joints going to be producing some, and these other extremities are going to be. But that's 500 probably when it's walking. Other times it's maybe 200, 300. And then on the lunar surface, it may be a lot less because you're not toting around as much mass.
Right. So, I mean, that's about, at room temperature, you basically need about 2 square meters of surface area, which is about what a human has. So if it was distributed all over, it would be, you could keep it at room temperature without adding vanes. But I would also say that, I mean, the nice thing about radiative cooling is that it's proportional to the 4th power of temperature. So you got, we're talking about cooling at 300 Kelvin, but if you bump that up a little bit, then you need, like the parts of Optimus that are not the battery can likely tolerate much higher temperatures. So, even if it's running at 400, 450 Kelvin in the joints, and that will also dissipate some, like that increase in temperature in the joints will also you'll have this linear relationship of how well it dissipates to the rest of the skin. So I would be surprised if you needed vanes for regular operation, and for charging, if you just charge slower.
Yeah, you either charge slower or wherever you're doing the charging, that unit deals with it.
Yeah,
Because again, it could circulate that coolant through you, and then it figures out how to dump the heat energy. And it could be as simple as it does it. Say it wouldn't be called geothermal; it'd be moon thermal or whatever, lunathermal, where you just dump it into the regolith, which is already pretty cold. So you've got a nice heat reservoir, or let's say lack of heat reservoir that you can dump energy into. So there are situations like that definitely. So I see as like the recharging infrastructure as being something that should be completely separate from the bot. The only part of the charging infrastructure for the bot is the port that it plugs into, and that's it. All the other electronics, everything else would be somewhere else. Unless, you want these vanes that it's walking around with to actually be solar panels.
Yeah.
And didn't Blue Origin, don't they have something kind of like that also?
Do they? I don't know.
Well, on
they're
the lander, they're talking. Remember, they were showing the solar panels on there, and also some way of being able to dissipate, to radiate away heat, because of the they want to use hydrogen, and the problem with hydrogen is boil off, so they constantly have to do something to chill it. And so they've got like something, and it looked like you might almost be able to sometimes combine the two systems together.
Yeah.
That you might put a panel up that's pointing towards the sun. So it's like picking up all this radiation. The problem with solar panels is they like to be cool.
Yes.
And when they get hot, they don't perform so well. So you might do something like on that, where you've got a cooling loop on the other side, or you could imagine a bunch of different ways. And so you have a radiator that's dumping everything off on the other end. So you never know. You can come up with some clever solutions.
I've actually done some math on that as well for Starship when the first renders came out, and it was like, where are the radiators? And we were trying to figure out, where could they be situated? And that was one of the options that I had considered, is like, can you put them on the solar panels? Now, in the case of Starship, they didn't have the wings initially, so it was kind of, can you use the shaded panels? Can you use the panels that are exposed as like a single layer radiative surface? And it's possible to make that all work out. One problem, especially when you're trying to cool liquid hydrogen, is you're trying to pump all that heat, and of course, as you well know, the higher that temperature difference, or the temperature multiple from your cold side to the hot side, the less efficient your cooling, and B, the greater the power multiple that you need in order to pump that heat. So for cryogenics especially, it's best to have radiators that are as cold as you can manage, that to really drive down those power requirements. And on like near the lunar poles, you do have that option of going down to radiators that are in the 100 to 200 Kelvin range, if you just keep that completely shaded from the sun. So I don't know what Blue Origin is planning there, but it would be a surprising design decision. But then again, there are a lot of surprising design decisions.
It almost makes me wonder whether, you do come up with something that is akin to a geothermal system. That's going to require a certain amount of infrastructure, but do you start drilling into the lunar regolith around there? And then you just kind of tie that into wherever your vehicles are that are coming down. So that's assuming they're always kind of landing in the same area. If you're going off somewhere else, literally kind of off grid, if you want to think it that way, then you have to bring everything on your own. But within a certain area, why not? The lunar surface is pretty cold. So if you need something for cooling reasons, that would work maybe just as well. It is kind of ironic that, do you want to use like conductive cooling like that? Is that better to cool than the inky black of space, which is 3 degrees Kelvin, which, is like almost ideal for radiative? So I always say, wait a minute, what's the problem? It's like my pond freezes in the wintertime, even though the outdoor temperature will be several degrees above the freezing point, because the clear sky and everything like that.
Right.
So, and that's how I was always surprised, like, it's so hard to get rid of waste heat in space. I'm like, oh, okay. So if that's the case, then we have what is effectively a pretty cold ice cube right at our feet, both on Mars and on the moon.
Yeah, the one downside of lunar regolith when it comes to cooling that way is that it's, I think probably because of the lack of water content, it's and the fluffiness of it,
Mm-hmm.
it's a pretty good insulator.
Oh yeah, yeah,
So
Yeah.
you just don't have that.
yeah,
Like you
yeah.
would need veins in the ground probably to get that.
Exactly. In some ways, that's why geothermal works pretty well, because you have all that groundwater that's kind of helping to move the temperature around. But I mean, the other way to look at it is that when we start building these infrastructures, I don't think you're going to be wanting to dump the waste heat out into space. You're going to be wanting to dump it into your habitats, because you're going to have this perpetual energy crisis both on the moon and on Mars.
Right.
And so wherever, if you've got something that's generating waste heat that's going to be dumped because you need cooling somewhere else, there are going to be plenty of places that are going to pick it up. Plus, I think you'll have, thermal mass of the different regolith. It should be able to soak that up as well. So I would think that would be the logical place to put it, is store it for when you need it, or don't worry about the fact you get some excess heat, because there's no such thing as excess heat when you're out there.
Yeah, I mean, if you reduce the insulation on your HABs, then you just have a.
Oh yeah, that's the other way. Yeah, but I don't think anyone's going to reduce the insulation. It's like, still, just in case the tech breaks down, I want to make sure the insulation is working.
Yeah, so then in that case, the problem with the HABs is that if you have the insulation, then the human generated heat is enough to
really. Okay.
You still need to cool it. Like
okay.
If you have good insulation, then you still need to.
Now, if ozone, if you think ozone is crazy on that point, I had actually learned this from like one of the superintendents of my school district, because there was a question about, well, why do they only have like a short holiday in February? Why isn't it like a full week or something like that? And he said, well, part of it is because in February, it's really cold, and whether the students are there or not, they have to warm the buildings to like 55 degrees. And when the students are there, it naturally goes up, because they basically have these little heaters that are running at 98.6 degrees running around the whole day that actually warm the building up enough that the amount of heating they need to do for 55 degrees when no one's there versus 70 degrees when it is there, it's like the same energy bill. So you are dumping an
energy
awful
efficiency.
lot of heat. Yes, especially if things are well insulated.
Wow. All right. That was
sorry, we went off on a tangent there, right?
Yeah, no. I was fascinating, because we went right down to the Warren on that, and that was great to understand and to get a sense of. But do you think there's an option before we could look at Optimus on the moon? Do you think we could look at a possibility of Optimus on the ISS or another international space station? I mean, you have the Astro B that's been these are these cuboidal little robots that have been assisting astronauts on board the ISS for a few years now. They've been hugely successful. Do you think there's a case for Optimus to be tried out first on board the ISS?
Optimus is designed to work in gravitational space, not in zero G. So you wouldn't need the legs, because if you look at the B, it gets around really easily just with these little fans. It's really kind of amazing at how well it's able to control itself, because it doesn't have to worry about gravity. Now, having arms would be nice, but you might want to have more spindly arms, because the Optimus arms are probably overpowered for almost everything you'd want to do. Where Optimus would make more sense is probably not inside the ISS, but outside the ISS, maybe to do some of the EVAs, and you might design it a little bit differently to be able to move around in that environment.
Right.
And of course, there are already bots that are doing it, that are kind of look like a centipede, but they're a traditional, much larger arm. And in many cases, those arms are just there to position the astronaut to where the astronaut needs to be able to perform something. So I think you would see something, but sans legs. There's almost no reason for the bot to have legs in space.
I think it would be really cool to have a version of Optimus that has four arms instead of 2 arms and 2 legs.
Mm-hmm.
Just
kind of a Doc Ock.
Yeah,
I know. Just about to say that.
Yeah, because ideally if you want to really get leverage, you kind of want more than one arm grabbing your base, and you want to move along these handholds, and then you also can have 1 to 3 arms free for manipulating things, and that's
But also, in terms of the arms, I think
often wish that they had more arms that they could use. When they're going on those space ones.
Yeah, so probably 3 would be an interesting configuration. The question is, do you need 4? There'll probably be the arguments back and forth, just like when they were designing the Optimus hand. The question is, do we really need 5 fingers? And it's like most people say 3 fingers is like really all that you need. but they decided and even the CEO of Figure, I kind of asked him if he was able to drop some joint, would it be? He said the pinky, because it seemed like they had a big argument with like, do we really need the pinky? So when it comes to arms, you definitely need 2 arms. And the question is whether the third arm is like all you need to be able to grapple and move yourself around.
Yeah.
But it might come in handy to have a second one if you both hands are busy and like, okay, how do I go from one to the next?
Right. And then you have you have that whole question of the movement and bracing yourself and all that. But then there's also you can always use more arms for the work that you're doing, because there's often, if you just, we often run into that situation when we're doing work on Earth, right? Of wishing that we had an extra pair of hands, because you often have a work piece and then you have another piece that you're trying to join to it, and then you have one or more tools that you're trying to hold, or you're trying
which are effectively your third and fourth arm, the vice grip and everything else. That's what that is, right?
Yeah. So imagine if you had that option of the extra arm to manipulate things.
Yeah, and that again, that comes down to a lot of people thinking the whole thing through, and NASA has been very good at that, because when you look at the Apollo spacecraft and everything, I was sort of looking when the rover was going through and some of the elements on there, and them realizing, oh, we need to have an eye shade here and everything else, because they thought the whole process through. It's like, well, where's the sun going to come in? If we need to look in the eyepiece, there's going to be a lot of glare. Every little detail was already thought about on Earth. And of course, with a lot of simulation and training, they discovered, hey, it's a little bit hard for me to do this. We need to modify it. Because you want to make sure before you get up there, you've got every component that you need. You don't want to have more than you need, and you definitely don't want to have less.
Oh, I'm sorry. Speaking of number of arms, before we jump to another topic, I just want to give a shout out to Project Hail Mary, Andy Weir's book, and for those who have read it, Rocky. 5 arms.
5 arms. Okay, so that's an interesting creature.
Yes.
Do we have any? Are there any examples? I started trying to think. Are there any examples in nature of a 5 arm? I don't think there are.
Starfish.
Well, starfish, I guess, right?
Yeah.
Starfish. Yeah. Okay.
It's an alien, but
yeah.
The 5 arms come in handy.
They sure do. I can't help but wonder. There is a safety case to be made to deploy Optimus for extravehicular activities outside the ISS. Do you remember the case of the astronaut losing a toolkit or a tool in space recently, a few weeks back? Just God forbid you lose an astronaut. Fine. If you lose a bot, it's just another object in space. I think there's a case to be made, at least to begin with, for Optimus in some form or the other, for some limited use
for safety. I think it's about time. NASA has been working for a number of years on coming up with these kind of astronaut robots, and more than what we see, like the big Canadian armors going around. They really haven't done that. And I'm not sure why not, because it would make a lot of sense to be able to do something.
Absolutely.
The astronauts, the prep time they have to go through just to be able to get out. So if they need to get out there immediately, you have to wait a long time. The fact that you're using some consumables and everything like that, because you got to evacuate that. So who knows whether they're that oxygen whether it gets vented out or not. And then what the suits have to
limits to how long they can be out there. Sometimes
there's limits.
They run into these hard limits and they have to come back before the work is done, and then it's
So there's a lot of that. Whereas and it's very, very costly to put an astronaut out there for an EVA, and doing it with the bot, and especially if the bot could be there. We're not worrying about any lag, so telerobotic would be very easy. You could probably even control it telerobotically from ground. There wouldn't be that much lag. And a little bit of telerobotic even be possible in the moon, because it wouldn't be that bad a lag. And we already are doing, let's say, telerobotic operation within the solar system. If you look at a lot of the rovers that were sent out there, which are effectively a type of robot, at first they didn't really have much autonomy. It was, okay, we're going to study the landscape. Once we like the landscape, we're going to tell it to drive ahead so many meters and then wait. And then you had, of course, the very long transit time between the two, the delay. So it was very tedious to get them to drive. Now I think the new rovers have a little bit more autonomy. that they can start giving it goals, but still not full autonomy in the sense that it can just go ahead and do what it wants. It's still getting direction, and there still is that very long lag between them. So
in fact, that's
we're-
Ingenuity. The helicopter was
Mhm.
eventually deployed to do just that, to scout out for the rover.
Yes.
To go ahead.
So you can put more and more things like that where, yeah, it had to do a lot of the decisions of like, where's the safest place to land and everything else. So those were things that they could not. All they could do in the mission is say, here's the mission plan, now execute it. And that's what a lot of the other robotic explorers that we had, Pioneer, Voyager, and others, is that they were having to do some things on their own, but again, they were getting commands from Earth on what it was to be set up. If we start talking about robots that are doing, let's say, real work, they're just not kind of exploring a little bit here and we take a look and review what they're doing. They have some pretty big goal, it could be a construction project or something like that. They need to be able to operate independently. And that's when you need to have a really good artificial intelligence that's able to make the decision. So you give it the goal, dig a ditch over there, and it's got to figure out what's the best way. And it runs into any sort of obstacles. It has to figure out what that solution is going to be.
Yeah. I mean, you're eventually going to have to replace the ISS in a few years' time, and that would involve building a new space station. And I think there's a great case to be made for robots like Optimus to be used for that particular use case. You could even train them on Earth using imitation learning. You could also teleoperate them if need be to an extent. But I think a lot of those procedural problems and training could be taken care of here on Earth itself, and then you just send them up, and then it's kind of like a Lego set that you put together.
I will say
Yes.
that the space stations that are in design development phases right now that will replace ISS, I believe that all of the designs involve a lot less manual assembly than the ISS required.
Oh, for sure.
Yeah.
I mean, if you look at the Chinese station,
Sure, yeah, it was just like dock.
case in point, yeah.
Yeah. Now, if you look at the EVA that's going on here, it's rather interesting. You'll see that the legs are of absolutely no value the whole time. Yeah, it's so they're not really serving any sort of purpose to the asset. I don't know if they're just kind of dangling out there. I don't see them ever pushing it off anything else.
You can probably kind of use them like a tail to balance yourself and orient. Just like wiggle them to.
Just 5 arms should do, as long as it's tethered.
Right.
Yeah, you could have an arm just dedicated to just snapping the bot on to whatever hole it needs on the outside of the ISS as it moves along. Cool. And you could even have it teleoperated from within.
Absolutely.
Easily. And that's how the robotic arms are done anyways. Those big
The Canadian
arms that move around, those are all teleoperated.
Let's talk about another interesting thing that thanks to Elon, our lives are so interesting. But at the IAC in Baku last year, Elon was asked about the potential of, he sent his Roadster up, which is right now in space orbiting the Earth and Mars. So he was asked, why not build a rover? And if the Cybertruck could perhaps be a rover for the moon. And this is what he said. Listen.
Put a Tesla in space. This was like an amazing thing to see a Tesla actually flying into space. So you've already put one of the vehicles in space. Are you thinking about making a Tesla rover, maybe Moon or Mars? Any ideas for Cybertruck on the moon?
It would look cool, that's for sure. Now, the nice thing about electric cars is that obviously do not require oxygen to. They're not combustion cars, so they don't have to ingest oxygen from the ambient atmosphere. I think Tesla could easily make a car that like a Cybertruck lunar variant. Just get the moon option package.
You could get the moon option package with the Cybertruck variant. Wouldn't that be cool?
Yes, it would. And of course, the original lunar rover was electric also.
Yeah.
So for that very same reason, couldn't be internal combustion. The tires, I think, were like woven titanium mesh or something like that, because you can't exactly inflate tires on the moon.
Yeah.
And rubber probably doesn't get torn to shreds pretty quickly.
I mean, you could inflate tires if you have
You could, yeah. It's just that
air source, but
it's the source. Yeah,
it's
Yeah.
a point of failure that you don't
Yeah.
need.
And of course, they're trying to come up with airless tires here on Earth. You know, I know Tesla's been working with others. That it's the dream of everyone to finally have tires that you don't have to actually put air in. So and of course the other thing is I think the titanium mesh was very light. So everything is about making sure everything is as light as possible, as durable as possible. You have the electric propulsion that was in there, which absolutely made sense. And I'm not sure what batteries they were using at that time for Apollo, whether they were also using the same kind of hydrogen nitride battery or something else. But
It might have
even
been
in those
acid,
days,
but I'm not sure.
yeah, it could have been. Even then, they got pretty decent range.
Oh, it may have been iron phosphate.
The lead acid. I kind of wondered, man, it's the lead and the lead acid battery that bothers me. It's like it's heavy. So you're talking about mass. So we know it can be done. It does raise, interesting questions. When you look at the rover, do you really need to have it enclosed or not? So if you're going to have a Cybertruck on the moon, does it need to just be a buggy? Does it really need to be enclosed? Only reason you would do that is because you want a shirt sleeve environment. But if the idea is getting in and out, you're going to have to be wearing your spacesuit. So it's a lot easier to be able to get in and out of something like this. That's a spacesuit. I think there'd be a lot of variations on there. And the question is whether the Cybertruck stainless steel is like the ideal body that you would want to have or material for being on the moon. And,
so the shape of the vehicle is not really optimized for being a pressurized cabin, and the doors are also not ideal for having an air seal. But I think that there's another use case for an unpressurized rover that has that external skin, which is that, I mean, this is something that the Apollo astronauts really struggled with, is all that lunar dust that's being kicked off by the tires, just getting everywhere. So just protection from that, I think, would be really valuable. And as far as mass goes, I mean, that's the beauty of having something that could land 30 tons, 100 tons on the lunar surface and just drop one of these Cybertrucks on. It doesn't make much of a difference. I mean, it's a 3-ton vehicle, right, or 2.5 tons?
Yeah. And speaking of austere environments, I mean, I think there's a lot of visual signposting going on in this video that Tesla brought out a few weeks back. I mean, if you look at the beginning, look at these locations. I mean, it just could be on Mars or on the moon. For all you can,
And Ozan brings up a really good point that the Cybertruck was designed for a low coefficient of drag. It's not a problem on the moon. So, so you can come up with any shape that's ideal. And, I imagine almost the ideal kind of enclosure would be some sort of kind of bubble that would go around, it could be very light, but I agree, part of the idea is to make sure you're not exposed to regolith or anything like that.
I was going to say, in addition to that, the aerodynamics is useless. It's the flat surfaces are not good for that pressure differential. If you want a 1 bar atmosphere inside and you have vacuum inside, it's just it wants that bubble shape that Scott was saying.
Yeah, and I think that's what you usually would always see in those 50s and 60s sort of science fiction showing what these rovers look like. They always bubble out for that reason, is because it's much better for the pressure. And I mean, it's just also cool if it's like this kind of this glass sphere. And the question is like, how structural does it need to be? Because you're not going to be barreling along at 70 miles an hour. You're going to be going at reasonable rates, and then so it could be something pretty light. It just has to be, and the question is, does it have to, if it needs to be pressurized, then it's going to be strong enough for that. But if it doesn't need to be pressurized, if the whole idea is just to protect you from all the regolith that's going to be getting kind of kicked up as you're driving around, especially if it's like one rover is following another rover, the one in front is probably going to be throwing a lot up. So there could be two reasons for doing that.
When it comes to toughness of vehicles, I doubt you'll get tougher than the Cybertruck. Protect you from all that abrasive regolith.
That's true.
But it's interesting. I mean, I was thinking about the truck bed and the fact that Tesla's designed in such a way that there's a cover that rolls over it. There's a lot of space to carry scientific equipment, maintenance equipment, even life-supporting, life-saving equipment. If you had FSD on the moon, you could just have a couple of bots hanging out in the truck being driven around from point A to point B. It wouldn't take much, would it?
No, not much. And again, you're probably more like a variant of the cyber van or something like that is probably what you would end up seeing on the moon, because that'll be the version that's, let's say, less aerodynamic, maybe more roomy, easier to get in and out. A lot of people have asked about, can't Optimus just get in and drive the Cybertruck? I'm like, well, Optimus isn't very flexible. I think it would be really hard for Optimus to attempt to actually.
But does Optimus need to drive the truck with FSD?
No. But the point I'm making is, like, an astronaut wearing a suit, it's almost like Optimus trying to get in one of these things. So it would have to be redesigned to make it very easy for ingress and egress.
Absolutely.
It would be a really cool visual, though, if they had an unmodified Cybertruck with an Optimus in the driver's seat. Just land that thing and then have the Optimus drive. Have the Cybertruck drive Optimus around a little bit, and then Optimus get it.
Let's start a campaign.
That would be an amazing.
Let's get Elon to do this.
Oh yeah.
Of course,
that's when you say, the future has arrived. Yeah, when you see that soon, it's like that scene.
You've got Optimus, you've got the Cybertruck, you've got two of the main ingredients. You've got FSD, which is the third.
And you got Starship. It's just.
Oh yeah. This year is going to be really, really important for Starship, and I'm hoping we'll look at that in a subsequent discussion. But I just wanted to add this. This is Icon has been awarded a NASA contract to explore lunar surface construction using regolith. And if you look at these pictures, there's a Starship right there in the background, and this could so easily be Optimus and a Cybertruck as well, because if you're going to build on the moon, you need labor, you need trucks to haul your stuff around. Perfect use case, wouldn't you say? There's a lot of room for collaboration.
Yes, yeah. And when you think of the infrastructure that's required to deploy a crew of workers anywhere, it's incredible. The crew is just really the tip of the spear. And there's so much else that goes on there. All the logistics and everything else has to go on there. They always talked about an army marches on its belly. That's one of the things that Napoleon discovered, is that, a well-fed army is a good army. And it's the same thing, is that you're going into space, you have all these consumables you have to drag along with you. So, not just the air that you need to breathe, but also the water you need to drink and all the food and everything else. And a lot of times that infrastructure requires other people that are just there to maintain that. They aren't actually the ones doing the work. Exactly. So if you just go down that pyramid, it gets pretty bad. Once you start deploying the bots to do it, all that goes away. And so if you were to, I think Starship, and this is like a point of discussion. It may be you can send 100 people to Mars, or possibly 1,000 or something like that. I know there's different configurations people have talked about, but whatever that number is, you can probably multiply that by at least a factor of 10 if you are sending the bots instead, because the bots don't need to breathe, they don't need to eat, they don't need sanitation, they don't need a whole lot of space. They keep on talking about that whenever we wanted to go in space, we need to have some sort of hibernation. Well, it's really easy to hibernate the bot. So you don't have to worry about that. So you can send the force multiplier there is incredible, because not only can we send a greater number there, but when it's there, we don't have all this infrastructure that's required to really maintain them if they were people. So for these construction projects to work, yes, I think you want a team of bots doing most of it, with astronauts that are really there to be the foremen and to be kind of supervising everything to make sure everything is going all right. Of course, at the end of the day, we want them to build these colonies so humans can come there and actually enjoy it and see it in person rather than in VR.
Yeah, absolutely. And let's not forget, construction sites on Earth are notorious for accidents. You don't want an accident happening up on Mars. You'd rather lose a bot than a human, right? Any day. And it's just the moment you have a mishap in space, the sort of negative publicity that just grows around that is very restrictive for the evolution of any space program. So the last thing you want is to have a human casualty on the moon or on Mars.
Absolutely.
I just want to play out this video. It's interesting that this is the SpaceX animation of arrival on Mars, and it's really interesting. Well, I don't know if it was a conscious decision, but you don't see any humans walking around until you have starships land, and then you have humans inside that open the door and look out onto everything that's already constructed. And it's just a wild guess, but I suppose you never know with Elon's companies and his teams. There are so many Easter eggs always, waiting to be discovered. You don't have humans building any of that stuff. You just have them arriving, opening a door, and looking out.
So, one of the big question marks for me with SpaceX's plans for Martian settlement was that they've always talked about in situ resource utilization, generating local propellant to refuel Starship for the ride home, and using lunar ice for that. And that's a process that requires a lot of infrastructure setup. To you got to land somewhere that has access to ice, and then you have to extract that ice, you have to melt that ice, you have to purify that. You have to at least filter that ice. It's gonna have dust and dirt mixed into it, and then use electrolysis to separate the hydrogen and oxygen, and then use the subatomic reaction, combine it with the atmosphere, and then you have to cryocool that whole thing and pump it into these starships. And that's all of that is, that's like an industry on Earth, right?
Oh, absolutely.
And
absolutely,
the question in my mind was, how are they gonna set that up without people on the ground? And I was thinking, for early crewed missions, it might make more sense to bring the propellant with you, and I'd run some numbers on how to do that in such a way that you don't actually even need to refill Starship on the surface. You can kind of refill in orbit and land with enough propellant to get back. So a way to get crew onto the surface using Starship, such that they could then take those components and assemble it and set up a base that could enable more efficient transit. But this would dramatically simplify that. If you could send robots to do that work for you, even if they were teleoperated from, say, Mars orbit, that's something where it's easier to get to Mars orbit and back substantially. I mean, it does pose some additional challenges in terms of radiation exposure and the longer exposure to microgravity, but there are relatively easy solutions for that at Starship scale as well. So that might be a route to go down.
Yeah, I mean, to be honest, when I read this news about the Lunar South Pole oxygen pipeline and the plans for it, I was like, there's no way you could have human astronauts out there. It's not practical. It's just not logical. This is a perfect use case to deploy bots. I mean, it's not necessary that you have humanoid bots, but bots of other forms when it comes to developing infrastructure in space, either in orbit or on the moon or Mars. Do you see a route for Tesla to explore bots other than Optimus?
Oh, absolutely. Yeah, I absolutely see that. And I think the other thing I agree a lot with what Ozan said is that if you're looking for some of these resources, the Zubrin's original plan with the in situ was like, he's just taking it out of the air. Well, the air is right there in Mars. Doesn't matter where you land, you can just suck it in and you're okay. And however, he did have a problem with the supply of hydrogen. So at that time, it wasn't clear whether there was water ice available on Mars. So they were schlepping the hydrogen from Earth and then processing that into methane and to get also the water that you would need. And the only other thing they needed was the energy source. So they had a small nuclear reactor that would just be easily deposited wherever it had to be. So that was a pretty straightforward, easy infrastructure to set up. But once you start saying, oh, we're going to get ice, and it's like, well, are you landing like right next to a lake that you can just go ahead and throw a hose in there and suck everything up? It's like, no, it's like, you're probably landing somewhere where you think there's subterranean ice, and now you've got to do something to get down to get it. So it's like, oh, already we're going to have to start drilling or doing something like that. And we've already seen what happened with the rover on Mars, that it turned out it's a lot harder than they thought to be able to drill into some of those rocks. So if you're trying to do something of that scale, it gets pretty tough. And then I agree, it's the water's not going to be pure coming up. There's going to be everything else you have to do with it, all these other chemical processes. I suppose potentially, some of the infrastructure that you're just kind of dropping in there and it almost like Legos plugs together, but there's still going to be that aspect where you're out prospecting and trying to find the thing you're tapping into. And that's going to be challenging for people to do, just like the pipeline you're talking about. So it may be you think of designing a pipeline very differently than you do on Earth, where you're expecting that you're going to have a lot of workers that are out there, all these roughnecks that are just going to be out there bringing these things in there and bolting them together and busting their knuckles all the time as they're just taking the wrenches and moving all that around. And a lot of times it's done that way because that's like the cheapest way to be able to build it. But now you would be thinking a little bit differently. It's like, okay, how do we come up with something that we can deploy over this area that's very rugged, where we can do it almost autonomously? And a lot of these things can be done autonomously. Yeah, maybe they involve a humanoid bot, or they involve some other form of specialized automation that's able to do the job really well. Because all I'm thinking is that if Optimus is out there, it's because we have different sections of pipe that we have to fit together for some reason. But there could be a completely different way that the pipes are put together that can be done with some other kind of agent, where it's able to go in and maybe do internal welding as opposed to having to take nuts and bolts and wrenches and everything and try to tie them down. So there would be other ways of thinking of the pipeline problem different than what we're used to thinking of here on Earth, because let's say the incentives and what the costs are very different than what you have here on Earth. So again, the Cybertruck's going to look different because it's a very different environment, and you're also going to do different things that may make it least costly. Whereas if you took that same decision on Earth, you would say, well, that's the more expensive option. Why are you doing that?
I mean, the nice thing about the humanoid form is that it's much easier to translate from, well, we know how to build things with humans to now we mimic that with robots. That you don't have to invent a whole new way of assembling or manufacturing or prospecting. So that's something where
exactly.
we might see more Optimus use both on Earth and off world than we might otherwise expect for efficiency reasons, just because of that ease of translation.
Yes.
And
that's key. Yeah, because what it means is that you can very easily replace one with the other. Mm-hmm. So if the bot is down, a human can go in and do it, and vice versa, because the tooling is compatible. Industrial robots, the end of arm tooling is not compatible with any human, and vice versa.
Also, it's interesting, at that same event in Baku, Elon was asked about the possibility of Starship being used as an outpost in space for scientific research, and perhaps as a smaller version of a space station. And Elon seemed to feel that it was very within the realm of possibility.
Well, there's precedence for that already. It was called Skylab.
Right.
It's just like the upper stage of the Saturn V and turned it into a space station. So yeah, if you've already got something,
an even bigger transformation.
Yeah. So, but still, it's the same thing. Is that you've got something that you already know how to get into orbit, and all you have to do is just repurpose it or reconfigure it a little bit for that particular situation. So yeah, I think it would be absolutely perfect. That it is sort of silly that what we're doing right now with the space station is it was built because it had to fit inside of something else. And so everyone else is thinking the future, what we want to do is we want to, stick these things in a fairing and everything else. And it's like, well, why not just make the thing that goes up there the fairing to begin with? It's all the same mass. And then rather than bring it at home, you just decide to leave it up there. And then that means you could throw a lot more mass up there because you could get rid of the ailerons on there. You can get rid of all the heat tiling. I mean, there's so much stuff that you don't need because you don't plan on bringing it back home. And then maybe you figure out something like with the extra Raptors on there. I guess you kind of need it to get up into orbit, but you never, they could come up with some version. You just drop the skirt off or something like that and retrieve it some other way.
I mean, do you even need to retrieve it, right? Something like a crude hab of that scale, just the development cost alone is
crazy,
pretty substantial. Yeah. I won't make up numbers because we have numbers for the ISS and we have numbers for Starship, but it's there's a wide range, let's say, but it's a very large number. And Raptors,
didn't Elon also mention somewhere that the effective space of the ISS was very close to a Starship?
Yeah,
could be.
Yeah. They're both on the order of 1,000 cubic meters of volume, and there's some wiggle room in that. HLS is going to have less pressurized volume because it's going to have that unpressurized deck, but you could use more of that space for pressurized volume, and then there are suggestions about stretching that have stretching Starship, right? Partly for propellant, partly for longer fairing. So you could realistically go up to 1,500 cubic meters without increasing the diameter or doing anything crazy with the shape or reducing the propellant mass, which you can also do. You could reduce the propellant mass to maximize that volume mass ratio.
I believe that was the solution he was looking at.
Yeah. So you could go up to 2,000 cubic meters or more. Which would be larger than the ISS.
Than the ISS, yeah.
And I think that going back to the Raptors, if they're producing those at somewhere on the order of $1 million a piece, especially if they have already, and then if they're pre-flown Raptors, what's the cost of just leaving those on?
Yeah. And again,
use them as a M-mod shielding on the.
The
back of it.
That was something that we had talked about before also, that whenever you have these expendable versions of Falcon Heavy or stuff like that, you just find those Merlin engines that are sort of towards the end of life anyway and put them on there. So you're never really throwing away anything that's new. So they've already had a lot of utility. Yeah, that makes sense. And I'm sure the cost of trying to retrieve those things then is just not going to be worth the manufacturing cost, right? At that point. And you never know. It could be that, some couple decades in the future, someone finds some need for that thing to be able to, good thing we have these engines. Now we can just blast yourself on the way to Mars or somewhere else, the Vogons are coming.
Or just cobble something together for a rescue mission.
Yeah.
Certainly the main tanks and RCS, you can still use those, like the refueling, because ISS needs reboost and maneuvering, right, capabilities. And that's something where you would have that built in with, at the very least, RCS, even if you didn't want to turn the Raptors on.
Exactly. Yeah.
All right. I have to ask you this question. There's been so much talk about retiring the ISS. There's just, do you deorbit it, let it burn up? And then there's also the counter argument of why not just take it to a Lagrange point and just let it hang out there as a testament to our spirit of endeavor and just as a testament to the achievement of our race. Where do you guys stand on it? I'd hate to see it burn up in the,
I think that I'm okay with ditching it. I think if we're going to preserve it, I would prefer to bring it to Earth in pieces and put it in a museum. I think that moving it to a higher orbit runs the risk of generating a lot of debris as that falls apart over time. It would be, we have this plastic outside rug that we bought some years ago, and in the sun it has basically started flaking off, and it's just like breaking up into these tiny fragments, and that pains me to think of the amount of earth destroying waste that's being generated by that. And while space is large and you don't have biology out there, orbital debris is a real problem. And if you have chunks breaking off of the ISS, or some tank blows up and you have a bunch of little pieces, or something hits it and it's just like falls apart into thousands of pieces.
But space is also phenomenally big.
It is, but we're still talking about putting it somewhere in the Earth moon space, like Earth moon system, right? So the chunks that will fall off of that, especially if you put it in a Lagrange point between the Earth and Moon, right?
Right.
And a lot of them will tend to end up in either lunar orbit or Earth orbit. And lunar orbit is even more susceptible than Earth orbit because it doesn't, you don't have that atmosphere to gradually deorbit things. You still have the gravitational perturbances to deorbit things, but it's I just wouldn't want to. I would hate for the ISS to become just a source of trash.
There's a lot of junk on there. Yeah, you're just looking at that. It just looked like things that could start flying. It's good that you kind of went first, Ozan, because maybe it kind of convinced. I was hoping it'd be something we'd try our best to preserve it for the generation that could really do something with it, whether it turns it into a museum in orbit that people can go to, they put a big bubble around it or something like that, or whether they figure out how to then bring it down piece by piece as necessary as the technology is there. The problem is that the time in between, it's like, it does pain me, this idea that we're just going to throw it somewhere in the deepest part of the Pacific Ocean, or the most remote part of the Pacific Ocean, never to be seen, because we have so many historical relics in space that we've never been able to bring back. Sputnik burned up decades ago, and so we only have replicas in museums. And the only authentic pieces of rockets and stuff we have are ones that never flew, at least until SpaceX. You can go to NASA and it says, well, that one actually flew, but the ones in the rocket garden, no, they built it, but it never had a chance to go. So,
we do have those like, F1 engines that Bezos fished out of the
right.
planet.
So he was able to get a few things, but not the full Saturn V. And the Saturn V's that are on display are, again, the ones that they didn't get to fly.
Yeah.
So, I mean, like, part of it is like, oh, they should just make it part of like an O'Neill cylinder someday. That's just kind of in there that everyone can go and take a look. And the only way you can do it is to make sure it's there for that next generation, as opposed to just like disposing it. So that's my initial reaction. I'd love to see something like that, but we could condemn that generation from ever being able to do that if low Earth orbit is full of space junk, because the ISS just kind of slowly broke apart. It needs to be maintained. I mean, I agree. It's just because it's uninhabited doesn't mean chunks won't start falling off. They may actually start falling off more rapidly than when they're there. Just kind of service it and make sure everything is okay. So that could become a potential danger. Yeah. I know it's like,
I'd be more okay with sending it out into interplanetary space for some, and it comes by every once in a while. We have ISS.
Yeah, but the question is, how risky would that be? I mean, you're trying to boost that whole thing. That's going to be a lot of delta V. And what happens if it breaks apart on the way? You're probably more likely. So if you were going to preserve it, I would just say do whatever you have to do to keep it boosted in low Earth orbit for as long as you can. And that if something looks catastrophic, that you figure out how to deorbit it right away. But I understand why the administrators, everyone's think like, it's going to be too costly to maintain. There's better replacements coming along, and it's a danger sitting out there.
You could tow it out with a fleet of basically Starlink sats with extra argon and a long tether, and just kind of gently.
But I'm just this is where I'm kind of concerned, because we're going to be transiting a lot of orbits to get out there. It's going to take a long time, and this thing has it's so much surface area on there that the chances of being able to do that without some satellite or piece of orbital debris hitting it, I would be a bit nervous about that. I don't know what to calculate. My gut tells me, well, it's a low probability. It's definitely not zero. And it might be that it's not 1 in a billion. It's like maybe 1 in 1,000 or 1 in 100, which is like, too risky.
Yeah, I hear you. I mean, the nice thing is that it would not take all that much to, like, the pressurized modules. Those would easily fit in the proposed Starship fairing, the Chomper. So if you were able to detach, and that's something where Optimus might come in handy. You don't necessarily want to do astronauts for that, but
to do that. So yeah, it'll look like something out of 007, where it comes up and just like that, grabs a piece of the International Space Station and brings it down. And that's the other concern is they're thinking of bringing it down in pieces anyways, right? Deorbiting it in pieces.
Oh, I thought
I think that's the idea.
Whole thing.
Oh, they were just going to push through. Okay, the whole thing. So,
I mean, I might not have kept up with it, but
I'm not sure, because I think there's a certain amount of risk in like tearing the modules apart.
Yeah.
When you do that, you could also have a lot of things go wrong.
Right.
So, because that thing's it's going to come down in one big piece. I mean, it's not much of it's going to burn up. There's going to be so much there. A lot of it'll
break up into a bunch bunch of.
It'll break up, but it's going to come down in some pretty big pieces. And yeah, you got to make sure they hit the target area right. That's going to be quite a big splash and quite a sight. I mean, it's like
it'll be a meteor shower over it.
Oh yeah,
you don't want,
but it'll also be a huge media event. I mean,
Yeah.
think about how the people want to go see when they want to see the solar eclipse or something like that. You know, people flock to where that is. If you know the day this thing is going to come down, there are going to be people that are going to want to go to wherever is going to be the best vantage point.
yeah,
Whether it's New Zealand or Australia somewhere, or some remote island in the Marshall Islands, somewhere out there. Or who knows how many people are going to charter a boat to get as close as possible to where it comes down, because that's going to be quite the light show.
Yeah, you don't want this happening. You don't want the Chinese rocket booster happening.
Yeah.
That was quite something.
Yeah.
See, that's amazing okay, so that was just the booster. That wasn't coming out of orbit, correct? That was, I think, just the first stage booster.
Yeah.
Okay, yeah. So at that point, they're not going to burn up. They're going to hit the ground with a lot of force. And what's I'm surprised is when they go over there, how much of it is still intact.
Yeah.
Yeah.
In those cases, it's like you'd think there'd be nothing left. It's like, oh, yeah, you recognize lots of the pieces here.
Yeah, but I personally, I would hope that at least some part of the ISS could be preserved in space. I mean, you're looking at space tourism being a big thing in the next few decades. I'm sure there'll be a whole lot of people who pay good money to go and just go and visit the space station or some part of it, maybe the cupola, and get into the cupola and gaze out and get that experience. It'll be a great shot for Instagram. And let's not forget that this entire program and the ISS is a testament to global cooperation, even during the peak of the Cold War. So it just might be a bunch of metal and stuff up there, but the significance is huge. It's just historic, and I would hate to see all of it go. Yeah,
it's like what do we think? Was it? Remember, historically, was it the Romans or Cleopatra's army that basically decided they had to burn the Library of Alexandria? Because it was of strategic importance on that particular day for their survival. Yet the cultural heritage that was lost there. I mean, it's like, and it's almost the same thing. This is kind of like the Library of Alexandria in a way. Like you say, it was a huge testament of not what the Americans could do, but what the human species could do, because it was an international project. It's showing the cooperation, that incredible symbol of the ingenuity and the desire for not for competition, but for cooperation. So in many ways, you lose that. And it's something you can see in the night sky.
Yeah.
I see it occasionally. I'm like, what's that bright thing? And I look it up. It's like, sure enough, the ISS just went by and wasn't aware of that.
Yeah, for sure. I think, Dr. Walter, you and I are a lot more sentimental than Ozan Bayo.
Yeah.
Yeah, I mean, to me, it would be nice to preserve, but I am thinking more about
heartless. You are heartless.
Where are we headed? Ultimately, it's hardware. I'm really glad that it's well documented. The history of it, all the work that went into it, the cooperation that it involved, all the science that was done on it. It's great that we have this kind of footage that we don't have for a lot of things that were lost in the past.
Yeah.
Yeah, I think the only thing about that is, if we did bring it down and brought down different modules, whether the different modules that go to the different countries of origin, or they go to one place, and that how much would be more contentious than anything else. It's like, no, it's going to go to the Smithsonian in Washington or something like that. They're like, no, we don't want it to go there. It's like, yeah. So unfortunately, if it does come back down, they'll probably be broken apart, and all the pieces will go somewhere else. Yeah. But there are tours to see the Titanic. We know it didn't turn out so well that summer, but there are people who can actually go down and view the Titanic. And if it ends up at some spot in the Pacific Ocean, I'm sure some future generation will figure a way to go down and view it and maybe collect it. So maybe it's not completely lost.
Thank you so much, both Dr. Walter and Ozan. I'm just going to pull up your Twitter profiles. That's Going Ballistic 5. That's where you can find Dr. Walter on X. I keep saying Twitter, but it's X. And you also have Ozan at Billik Ozan. Thank you so much. It's been such a pleasure talking to you about so many things. We got to do this more often.
Yes.
Yeah, that'd be great.
And we get the next Starship launch to talk about. That's going to be coming up.
Oh yeah, absolutely.
So that's on the agenda.
Thank you so much.
All right. Yeah. Thank you too.